Hello, my name is Richard Graham. I'm a technical product manager for Unreal Engine. I work in the virtual production team, and I work on the performance capture tools, which is why I'm speaking about this topic today. My background is I've been at Epic for 2 years, and prior to that, I was in film visual effects for 17 years. Latterly as a motion capture supervisor and virtual production supervisor, trying to do the kind of workflows that I'm going to talk to you about today. So the kind of overarching message with this talk is that we believe that performance capture is really the future of creating animation in Unreal Engine. And there's a couple of reasons for that. The main one is that demand for animation will continue to increase as we, make good on our metaverse ambitions. And performance capture can really help to produce that animation that's needed in such great volume, because you can't keyframe everything, and so you want to save your keyframe animation capacity for when it's most needed. So performance capture is really, really good at generating a lot of realistic animation very quickly. You can have minutes of animation within minutes of recording, especially if you've got multiple performers. But that does produce a challenge of organization for anyone who's sort of done like a day's shooting of motion capture in Unreal Engine, and even in other packages. It does generate a lot of data, especially once you start to factor in things like the performers' audio recordings, any kind of witness video that was running at the same time, potentially screen recordings of the real-time renders, a virtual camera as well. So towards the end of this talk, I'm going to address how we're working to alleviate some of that organizational challenge for you. So I'm not going to stand here and say that visualizing motion capture in real time is a new thing. It has been happening for many, many years. And in the sort of the period of my career, I've seen big improvements in real-time solvers, and also cheaper and cheaper mocap systems becoming available, making it democratized. But just to sort of prove the point, performance capture was used on these projects stretching back more than 20 years. And while the amount of performance capture has grown, there's kind of hit a ceiling in terms of the quality of the visualization that was possible on these projects and many others. And just to kind of prove that we're not hiding anything, we don't always use Unreal Engine for our performance capture internally as well. And obviously we want to try to get to a point where we do use Unreal Engine as much as possible, and certainly for our Fortnite cinematics, which is what this clip's from. So obviously we can make it look so much better in Unreal Engine, and so what we need to do is make it better, faster, and easier. Now, the make it look better bit is work in progress, but is obviously that we're probably the furthest ahead on that. And making things faster and easier is the kind of the two things that we need to work on with performance capture workflows going forward, and that we're making some progress on, and I'll talk about that later. And what that will do is generally make performance capture more accessible to more people, because previously it was AAA feature films and AAA games that needed it, and gradually, as the technologies become more accessible, it's trickled down and come into a wider range of projects that are not just smaller in budget, but also different in their genre and different in their ambition of storytelling. Things like bringing a director in who's only ever worked in comedy. It's very hard to do that with keyframe animation when there's such a slow cycle of turnarounds on new versions. But if you're in a performance capture stage and that director is engaged with performers, then there's a spontaneity that you can capture there that you couldn't do previously. And if we make the technology easier, those kind of creatives can come into a performance capture stage and not be quite so overwhelmed by the level of technology and the level of futzing around with ROMs and all the kind of data capture aspects that you have to do well, but that should be easier so that they're not impeding your progress. Okay, so just to sort of prove that we're pushing forward on this kind of thing internally. This is from a Fortnite short that we made a good number of years back, but basically trying to work with everything being previewed live in Unreal. And to my point about comedy earlier, bringing genres that require some kind of like spontaneity and performance in the capture in as well. And then also, obviously, we've got our MetaHuman Animator product. And I'm just sort of showing this as an example of something that that I saw and had some involvement in, where the rig was not quite finished, but looked tremendously impressive. And we were shooting, and then within 20 minutes of a cutting on a take, we could view that animation back in Sequencer and just scrub it and see it. And in my previous experience, that process had been 3 to 6 weeks. On a traditional, it wasn't because it was visual effects. It was just because the tools that were available then weren't as advanced as MetaHuman Animator. So moving from slow offline solves to near real-time solves, and then hopefully in the future to full real-time solves. So hopefully I can get you to come along with me with the idea that that doing performance capture in Unreal is great, and that's a good idea, but there are questions to answer as to, well, how do you do that? And so the first thing to consider is you're recording directly in the engine. There are obvious advantages, like you can visualize things with lighting and assets that are closer to what your final presentation will be. You don't need external packages and therefore file imports. And our retargeting technology continues to improve over time and has improved quite a lot over the last couple of versions of the engine. But there are things to negotiate on the demerit side. Recording can be complex. Take Recorder is has quite a lot of options. And one question I'm asked quite frequently is, well, what happens when performance drops? Because maybe you're working with an environment that's been kit bashed together very quickly and it looks awesome, but there just hasn't been time to optimize it fully. What happens when your performance drops there? What happens to your recordings, and how can you mitigate that performance? So basically, there's 2 ways of recording stuff in Take Recorder. The first is to just drag in this case, because it's a character, drag the skeletal mesh actor into the Take Recorder. The second is to add the source of Livelink data that's driving that skeletal mesh to the recording. And I'll explain why you might want to do one or the other. There isn't a definitive answer, but I'll give you kind of like a heuristic for how to decide which one you should choose. So just to break down what's happening when you are recording in Take Recorder. So you kick off a recording, and of course, time starts advancing. You will probably have a source of time code, and I'll mention in a bit more detail how you can get a source of time code. So effectively, the frames are bound to the intervals of timecode. And then the game thread is being evaluated here. And on frame 1, it's good. On frame 2, it ran a bit long. And consequently, everything's kind of shuffled down the line from that point forward. But if we look at the Livelink data, because Livelink data is evaluated on a separate thread, so it's not inhibited by stalls in the game thread, the Livelink thread will just keep evaluating. And in this case, in my example here, I'm showing it running at 60 FPS, and the timecode is running at 30 FPS, so hence the 33 milliseconds. So if you record the Livelink data over time, you will get a graph or a curve that looks something like that. You'll get consistently laid down keys across the frames. And if you record the actor when your performance is not as you'd like, then you get a curve like that, where the keys fall outside of the frame boundaries. And what's really happening is that Take Recorder is waiting for all of the animation to be evaluated at the end of the frame, and then it's stamping the key values on each of the bone transforms. So obviously, you're going to prefer one over the other in the event that the performance is not where you want it to be. So basically, that's your heuristic. If you're going to record some data and your perf is good, the scene's relatively light, maybe you've dropped the scalability settings, then you can record the actors. And if you really, really can't get there with the perf, then you can record the Livelink source data, and then the resulting recordings, there's a right click in the GUI menu to basically bake animation clips offline and after the fact. So you will then get animation clips that are baked at the tick rate of the sequence, which in this case would be 30 FPS. So why is timecode important? And apologies if that seems like a really, really, really obvious thing to ask, but as we move from motion capture to performance capture, that you have to accommodate many devices producing the performance of a person. I mean, worst case probably would be body, gloves for fingers, and then facial capture from some kind of video capture device or depth capture device. So you've got all those devices. Some of them are running at 30 FPS, some of them are running at 120 FPS. What do you do? Well, how do you synchronize those elements together? You use timecode, and you can synchronize while recording, and you can also synchronize in post in sequencer. You can synchronize audio to the sequencer timecode and the animation the same. So what you want to do is use a media profile, which is available in the Media Utilities plugin. And you want to set up a timecode source. You want to set up a custom time step. The time step is basically the thing that's driving the frame interval when the engine's rendering. So I'm just in my GIF here. I'm adding the timecode stat to the viewport, and then I'm opening my media profile and setting my timecode provider and my genlock provider, which is the custom time step. So it's worth noting that in 5.4, we added the ability to have Livelink sources as timecode providers and genlock providers. So that means now that you can basically drive your engine's tick from your motion capture system, and you don't need, as you have had to in the past, use the media capture framework, where basically you're bringing genlock in over an SDI cable and genlocking the engine that way. So that's another thing that we're trying to do to basically increase accessibility. It means you don't need an extra card in your PC, and you don't need necessarily a SDI genlock distribution network on your mocap stage or mocap facility. So if you're just opening a new project and to do performance capture, these are the plugins that you're going to want to enable. I think Take Recorder is enabled by default, so you shouldn't have to turn that one on. But these are the ones that you would be using. And as Media Utilities is the one that has the media profiles in it, and Virtual Production Utilities has some sort of helper classes for the genlock portion of synchronization. So we've also in 5.4 released a new product called Livelink Hub, and what it is it's a standalone executable that can take all of your animation sources on your network, or maybe it's just on your local PC, and then it broadcasts those animation sources to all of the editor sessions that are on the same network. Quite often people do performance capture shoots with multi-user, maybe one machine's just doing the recording, one machine's just doing the visualization. So this allows you to distribute the Livelink data. And it basically gives you a single source of truth for your Livelink data. You configure it in one place, and then it shows up the same in all the editor sessions. And it also works with UEFN, which is kind of one of the reasons we made it, but it also has benefits for sort of creators and for studios. So why did we create it? Well, before Livelink Hub, was created, you would in your editor, in your editor or your engine, you'd manually subscribe to each of the Livelink sources that were on your network, and so the flow of data would look something like this. So if you end up with like 3 Unreal editor sessions, then this gets quite complicated. And what Livelink Hub does is it kind of rationalizes it a bit and makes it simpler. So all those different sources go into Livelink Hub, and then they are automatically rebroadcast to the editors that are on the same network. So when you start an editor session, you don't have to worry about connecting to the Livelink sources. They're all there for you already. And I should say that this is also part of a longer plan to be able to stream into a running game in the future. We haven't really begun the work other than talking about it at this point, but that is definitely an ambition on our roadmap. But for now, this is for like, you can actually build your own game client that can receive Livelink data, but if we're talking about Fortnite, we can't stream directly into the game yet. So if you want to learn a bit more about Livelink Hub and how to use it, there's a tutorial on the Epic developer community, and there's a QR code there if you want to look at that in more detail. That also talks through the IK retargeting workflow. So another thing that we've added in 5.4 is a plugin called Livelink Input, and basically what this does is it turns your gamepad into a source of animation data. And the real reason for doing this is because almost everyone has a gamepad lying around, and so it's just a very accessible way of becoming familiar with the Livelink technology without needing to purchase a motion capture system or expensive software licenses to go with it. So here is an example of a puppet that I knocked up, and the data can be accessed in your blueprints, in your animation blueprints, and in control rigs as well. Also with Livelink Hub, it means you can have one game controller spitting the data out to multiple editor sessions as well. So another thing that we've added in 5.4 is a plugin called Performance Capture Core. And what this does is basically removes the need for having to create all of these boilerplate animation blueprints that you've had to make in the past for motion capture. So the top image there is of my performer, and you'd have to create an animation blueprint for him and then say what the subject is. And the bottom is my retargeted character. So there's 2 new components. There's a performer component and a character component that you can just add to a skeletal mesh. And I'll just show that quickly here. So on the left-hand side, I've got my motion capture performer, and I'm just I'm adding the performer component and then just selecting which Livelink subject, which performer basically is going to be driving its pose. And then on the right-hand side, I've got this giant rampage character, and I'm adding a retarget component to that. And then you just have to tell the retarget component which other skeletal mesh in the world you want to copy the data from, and then the pose is retargeted across. And this works in Editor and in Pi, and it's also in UEFN. So there are lots and lots of other tools in Unreal Engine that can be utilized as part of your performance capture workflow. So I'll just touch on a few of those here. There's the virtual camera tools. There's the movie render graph. So at the end of the day, if you recorded 50 takes and you need to render them out for the director to look at, the movie render graph is a place to do that. And then there's also the animation in Engine. And particularly in Animation Engine, there's layered control rigs, which make the business of motion editing the recordings after the fact much simpler, because you now can do it as an additive layer rather than having to bake everything to one rig and then add sections. So what are we planning to do for 5.5 and beyond? So at the moment, Livelink Hub just has a prefigured list of plugins that it supports. And what we want to do is basically make it work with the whole Livelink plugin ecosystem that exists on the marketplace and outside of that as well. So if you want to write your own Livelink plugin, you should be able to load it into Livelink Hub. And so with 5.5, you will be able to just load regular Unreal Engine plugins into Hub, and that means that the ones that are on the marketplace already should just work with it. And if you've got any internally as well, then you shouldn't need to recompile them for a different target. We're also moving to have the MetaHuman animator ingest workflow in Livelink Hub. And the reason for this is because we quite often see studios that have, say, 3 or 4 performers shooting with Livelink Face. And so they've got, at the end of a shooting day, there's a lot of video to process. And you might want to basically batch farm that across a bunch of machines. So the idea is to move the ingest process of MetaHuman Animator into Livelink Hub so that you could say, oh, all of this performer's takes should go to this machine and start processing. All of this performer's machines will go to this machine, and so on and so forth. So it's kind of like a job queue, and you can manage the job queues. We also want to be able to do data retiming. So if you've got a motion capture system that's running at 120 and a gamepad that's maybe being polled at 60 and video facial capture that's running at 30, just retime it all to 30 so it all arrives in the engine at the same time, so that there's an absolute minimum of like errors in where your keys are getting stamped and what your animation curves eventually look like. We're also going to add access to recording devices, i.e. video decks and sound recorders and head-mounted in any kind of real-time head-mounted camera systems that come in the future. If anyone's familiar with the Switchboard product that we have, Switchboard kind of does quite a few different things, and some people use it on performance capture, but it's mostly geared towards ICVFX stages where you need to spin up your nodes and manage the state of your render cluster. And then kind of as an add-on, it also has the ability to like trigger recordings and things like that. We would prefer to have the triggering recordings and managing your video deck, your sound recorder, your witness video cameras in Livelink Hub. So the kind of the place to trigger your recordings from would stop being Switchboard and become Livelink Hub. The performance capture workflow that we're improving and working on now is basically a workflow panel that will allow you to get up and running as quickly as possible when you want to shoot. So you'll be able to say, right, today we're shooting this session, give it a name, and then everything is stored in a kind of folder structure that you've predefined that's really consistent. There'll be helper classes for performers and characters. You'll be able to store like all the settings that are associated with a particular mocap performer. This performer's 5'8", and this is their proportions. This is the set of gloves that they were wearing, and reload that up from one day to the next, so you don't have to keep remaking those things, and be able to track all of this in a kind of database approach as well, so that if you wanted to have like one project in your facility for just shooting all your mocap into, you could, or you could shoot into multiple projects, but you could have you'd have a database way of looking up the animations that you've captured, so that you don't get that scenario where someone comes down and says, have you got some locomotion animation that we could use for this bit? And it ends up being harder to find than it is to just shoot some more. And we also want to improve the visibility of time code across the viewport, the animation assets, and video media. All of these assets at the moment do have time code in them, but it's a little hard, or in fact, in some cases, impossible to see what the time code is on a given frame of a recorded animation asset. And then beyond 5.5, we are going to look at making specific control rigs for motion editing to make that easier. There's an animation layers system coming, so that it's more akin to some of the animation workflows that people are used to in other packages. and we want to make the retargeting workflow tunable and recordable as well, so that if you're modifying the properties of the retargeting over time, like say, if a character goes to reach and touch the edge of a table, you need to make sure the IK is fully on, so the hand contact is solid. You'll be able to record that over time, because at the moment you can set it, but you can't record it. So yeah, that's what we're doing for 5.5 and beyond. And I think I've gone very, very quickly, and that's kind of it. All right. Well, thank you very much for coming, everyone. Thanks.